everybody, and welcome back to another video. Now, today we're going to be looking at the asymptotic expansion of the inverse incomplete beta function, looking like this. So let's say we have y of x is equal to the inverse incomplete beta function half 3 over 2 of x. Now, we want to derive a Taylor series of this thing about a point x equals 0. So we need to use the formula that y of x is equal to y of 0 plus y prime of 0 times x plus 1 over 2 factorial y double prime, sorry, that should be y double prime, not f double prime, y double prime of 0 times x squared plus some higher order terms which we don't care about. Okay, so let's work out what these terms are going to be for our inverse incomplete beta function. So y of 0 is going to be given by inverse incomplete beta function half 3 over 2 of 0, which is equal to 0. Y double prime, y prime of x is equal to, well, we need to differentiate this bad boy. And when we differentiate this, remember in the previous video we found that it's equal to inverse incomplete beta function half 3 over 2 of x to the power of a half times by inverse incomplete beta function half 3 over 2. Oh, no, not that. 1 minus inverse incomplete beta function half 3 over 2 of x to the power of minus a half. And indeed, when we put in y prime of 0, then, well, we get a beta inverse of 0 here to the power of a half, and of course that gives you 0 to the half, multiplied by something which will be non-zero. So, y prime of 0 will be a half. Y prime of 0 will be 0. Sorry, I don't know why I read that wrong there. Okay, so let's now figure out the next step. So, board plan is bloody useless. So use this. I mean, the board eraser is bloody useless. So let's just put some nice. Oh, there we go. That's a bit better. I think that's a bit wrong there. I think we can use something a bit better to wipe our board off with. Here we go. That's lovely, beautiful. This spray is much better than my previous spray, I have to say. Oh, okay, right. So we knew that y prime of x is equal to inverse incomplete beta function a half 3 over 2 of x to the power of a half times by 1 minus inverse incomplete beta function half 3 over 2 of x to the power of minus a half. So we just need to differentiate this again to give us our y double prime of x. Now, so far we've gathered that actually in our MacLaurin expansion, the y of 0 is 0 and y prime of 0 is 0. So actually these two terms are going to both be 0 when we do the Taylor expansion. So therefore, really we're hoping that this one isn't going to be 0 to give us something to work with at least. Okay, so y double prime of x, that is going to be equal to the differential of the first term. So that gives us a half beta inverse. Now I'm just going to write b to the minus 1, meaning beta inverse, inverse incomplete beta function to save space. That's going to be equal to the power of minus a half, times by, using the chain rule, the differential of this, which is just going to be beta inverse to the power of a half times 1 minus beta inverse to the power of minus a half. Then we've got to multiply it by this, because effectively we're using the product rule. We're differentiating this first and then multiplying it by this. So this is going to be equal to this, which would mean it's times by minus a half times by minus a half again, leading to minus 1. Okay, so we now need to leave this bit and differentiate this bit. So this will be plus beta inverse incomplete beta function to the power of a half, multiplied by the differential of this thing. Now the differential of this thing gives you a minus a half that we have to bring down, times by this to the power of minus 3 over 2, times by the differential of this. Now the differential of this, the 1 goes away because it's constant, and then we multiply it by minus the derivative of this. This will be equal to minus 1 times by, and I'm just going to move my multiplication down here, the differential of that, which is equal to beta inverse to the power of a half times 1 minus beta inverse to the power of a half. And if we simplify this, then we get is that y prime, well actually, let's just shove in y double prime of 0. Let's just go ahead and shove it in now. So y double prime of 0 is equal to, well, this bit. Now if you notice, actually no, let's just simplify it first before we do it, okay? So y double prime of x still, those bits cancel off because that's to the minus half, that's to the power of a half, so you get to the power of 0, which is just 1. That gives you a half, 1 minus inverse incomplete beta function half 3 over 2 of x to the power of minus 1. And then here we have a minus half times by minus 1, so that gives you plus a half, times by, well, we have an inverse incomplete beta function to the half times to the half, which gives to the power of 1, so that's just inverse incomplete beta function half 3 over 2 to the power of 1, multiplied by this thing to the power of a half times this thing to the minus 3 over 2, which gives the same thing to the power of minus 1. So we get, oh sorry, this should be minus a half, so actually this gives it to the power of minus 2. So this means that we get 1 minus beta inverse incomplete beta function, sorry, to the power of a half 3 over 2 to the minus 2. Okay, now we're ready to actually put our number in, and I'm going to do this black pen, red pen style. So we have y double prime of 0 is equal to a half 1 minus beta, inverse incomplete beta function of 0 plus a half times inverse incomplete beta function of 0 times 1 minus inverse incomplete beta function of 0. And indeed, all of these inverse incomplete beta functions of 0 are 0, so that goes away, that bit goes away. Now the fact that that bit's 0 means this whole term goes away, so we don't even have to worry about the second one. And actually what we're left with is just a half. So we can put it back into our expansion. Now this bit was 0, this bit was 0, so our y double prime of 0 is now a half. Now this board looks a little bit messy, so I'm just going to rub off all of this junk. So effectively, we have y prime of x is equal to y of 0, which was 0, plus y prime of 0 times x, which was also 0, plus a half y double prime of 0 times x squared, plus some higher order terms. And we know that this thing is just a half, so we can replace this with a half. So what we finally get is that the y of x, which is equal to this, so our inverse incomplete beta function, half 3 over 2 of x, is equal to, or rather the Taylor series is equal to half x squared divided by 2 plus some higher order terms which go from x cubed. Now you might think there are also some convergence issues with some of the higher order terms, and actually we're beyond the scope of this video. If you do further mathematical analysis, you find that actually this Taylor expansion is perfectly valid about x equals 0, but I can't be bothered to do that here, so just accept that these terms indeed converge, and in particular when x is much less than 1, then these terms can be neglected. Okay, or in other words, the inverse incomplete beta function, half 3 over 2 of x, is asymptotic to x squared over... oh dear, no, balls, I made a mistake there. X squared over 4 is asymptotic to x squared over 4 as x tends to 0. So that's another mathematical way of putting it. Both of these are perfectly valid, and this is the proof of the thing that we used in the previous video. So thank you very much for watching, and have a lovely day.